I've always said I don't need a 3D printer, but here I am with one. How did that happen? Stick around to find out how, and also perhaps whether you might or might not rethink owning one, even if you're a non-techie person or you're as opposed to the idea as I was. An old dog can learn new tricks, at least if he really wants to. Hi, I'm Gary. I'm a retired electrical engineer who makes videos about technology subjects that happen to interest me as a consumer and user of such things. If you followed this channel, you may remember that I make a point of claiming I don't buy stuff just to do YouTube videos about it. At my age and state of decrepitude, I'm only willing to devote the energy to making a video about something I actually use. However, I've been saying for years that I had no use for a 3D printer and I wouldn't buy one. Why not? Well, I had the impression that most of the stuff people print on them were things that didn't particularly interest me, and I didn't want to take on what looked like a steep learning curve for the technology just out of curiosity. But as you probably already know from the title of this video, I have a 3D printer now. How did that come about? And if you're of the same mind as I am, might you consider having one also? First, I should explain how this came about. I have a brother-in-law who's a retired science teacher, and he also has a bit of an artistic bent. He's had a 3D printer for years, printing any number of educational and/or interesting objects, which he gives to his grandchildren or displays around his house, or even gives them to me. One of my favorites, for example, was this 3D printed map of the U.S. that had to be assembled like a jigsaw puzzle. Each state was a separate unlabeled piece, recognizable only by its shape. My grandchildren put it together in no time flat because they'd just been on a cross-country trip. Some other examples he's printed include this enclosure for an Amazon Echo Dot and this model of a dinosaur skull. Or how about some weird gears, or a dodecahedron, or even a 3D printed ping pong ball, which didn't really bounce quite right, but oh well. Hang on, I'm getting to the point. He just bought a new 3D printer that's much nicer than his old one. It's totally enclosed for heat and noise control, has automatic bed leveling, a built-in camera and Wi-Fi, so you can print directly from a PC while watching the printing remotely. You get the idea. And he insisted on giving his old printer to me, in hopes of making me a convert to the technology. Nice of him, but given my past attitude toward 3D printers, why did I accept it? I'm an engineer. My shtick is mostly practical stuff. Well, the reason is basically because I discovered that there actually are practical applications of 3D printing, even for me. For example, if you saw my previous video on my do-it-yourself portable power station, I needed to mount some Anderson Power Bowl connectors on top of the box. The commercial panel mounts seemed really expensive for a piece of plastic, so I wound up buying a cheap 3D printed one from eBay instead. And I recently discovered the plans for a 3D printed enclosure for this gadget I bought from AliExpress. It's basically a terminal strip that lets you use an old PC power supply as a multi-voltage source for testing stuff. But the board, as you can see, has a lot of exposed terminals that could be accidentally shorted with probably unfortunate results. So my brother-in-law printed this nice little box for it that makes it safer to use. I've since discovered a few more practical items that look useful to me, so I thought I would make this fairly simple video describing how my entry into 3D printing has gone. Now, there are already a lot of YouTube videos that will tell you pretty much everything you need to know about 3D printing. So this isn't going to be a major tutorial, and it certainly isn't going to be a buy this and do it this way one. My goal here is just to show and tell on how a complete novice to the technology has managed to get into it without getting bogged down in a huge lot of details. If the prospect of a big learning curve has put you off, as it did me, Hopefully you'll see that it doesn't have to be as bad as I at least thought it would. So what do you need to start 3D printing? You need a printer, obviously. You need the material that it uses to print something with. You need a model of the thing to be printed. And you need a way to translate the model into printer instructions. I'll go into all those in a minute. But first, if you're bothering to watch this video, you may not know how a 3D printer works. So I'll give you the 60-second explanation of that. Mind you, we're talking consumer-level 3D printers here, which are pretty simple devices in theory. The most common ones, like the one I now have, are called FDM printers, which stands for Fused Deposition Modeling, if anybody cares. They build objects using a plastic-like material called filament that comes on a spool. Looks kind of like really heavy fishing line. The business end of a 3D printer has a geared mechanism that pulls the filament into a heated block, where it gets melted and then extruded through a nozzle that's only a fraction of a millimeter in diameter. While this is happening, this whole assembly is being moved around in 3 dimensions by an arrangement of motors and drive screws. This lets that stream of melted filament build up an object, usually in layers from bottom to top, starting on a base plate. It's kind of like a high-precision version of a hot glue gun, except the result is a permanent object and not just a blob of glue. Now let's look at the parts of the 3D printing process. I'm not going to talk about choices in printers because I didn't choose mine. It was given to me. It's a Creality CR10 Mini, which is a 7-year-old model that's pretty basic by today's standards, but it's still capable enough for my use. Most common 3D printers are fundamentally similar, even if they have more belts and whistles than mine. The filament used for 3D printing comes in multiple sizes and colors and a lot of different material types, each of which has its own strengths and weaknesses. You could make a real research project out of choosing one. Here's a table that lists some 30 different varieties. My brother-in-law saved me the agony of choosing one by giving me a bunch of PETG filament, which is polyethylene unpronounceable something glycol. It's fairly general purpose, so I'll worry about the other types if I need to. Now, given that you have a printer and some filament, the process of printing a 3D object with it comes down to 3 steps: obtaining a model in a form the printer can use, preparing the printer, and actually doing the printing. So how do you get a model of an object that you want to fabricate? There are at least 3 choices. First, if you have the knowledge and access to the modeling software, you can construct the model yourself. That's a whole other learning curve that I'm not prepared to take on at the moment. But Tinkercad is one example of free software to do this if you're interested. Second, there is software available that lets you build a model from photos or videos of the object you're modeling. Obviously, that only works if you actually have the object available. And I don't possess any of the objects I want to model, so that's out for me. The third approach is the one almost all novices like me will use. Namely, find a model that someone else has already built and use it. There are a number of websites that make 3D models available to be downloaded. Probably the biggest and best known one is Thingiverse, which has well over 1 million models available. But I put links to some alternatives in the description of this video. The great majority of these models are free. Great, I found a model of what I want. Now what? There are a lot of 3D model file formats, but normally what you download is an STL file. STL files are actually a representation of the surface geometry of an object, in the form of a mesh of triangles. The more complex the object, the more triangles it takes to represent its surface. But as we saw earlier, 3D printers don't print objects that way. They generally print them in horizontal layers. So the STL model has to be translated into something that the printer can actually do. The software that does this is called a slicer, because it converts the original model into a stacked series of horizontal slices that the printer can deposit one after the other. This is very much like the way some potters make a pot by stacking coils of clay. The result of the slicing process is a file of what's called G-code. This is a series of instructions to the printer which tell it how to move the nozzle to build the layers. A G-code file may also contain other instructions, such as how hot to heat the nozzle or the bed plate. What's left now is to prepare the printer to do the work. At least for my printer, this is a 3-step process involving the base plate, the filament, and the printer controls. The base plate is the foundation that the model is built on, so it needs to be cleaned and perhaps coated with something that helps the model to stick to it. My printer base plate is just a piece of mirror glass, so this is typically either nothing or a thin coating of glue from a glue stick. The base plate also has to be leveled so that the nozzle is the same distance from it everywhere, otherwise the model won't stick to it properly. This can be done by adjusting a series of threaded support points underneath the base plate while checking the spacing with something like a sheet of paper. Many newer printers do this leveling automatically, but it isn't that hard to do manually. The end of the filament basically gets shoved in a tube through the extruder gears until it reaches the nozzle. The spool of filament has to be located so that it can be pulled continuously to the print head. For a correctly set up printer, that's about it for preparation, except for checking for things like the nozzle not being clogged. Setting up a 3D printer for the first time obviously is more complicated than that, but I haven't had to deal with that yet. The final stage of the process is to load the G-code file in the printer and start the printing. My printer doesn't have a computer interface, so the G-code is saved on a micro SD card that the printer controller then reads. Assuming the setup parameters like temperature are in the G-code, the file just has to be selected and off it goes. It will instruct the printer to heat the nozzle and the bed plate to the right temperatures for the filament, and then control the speed and direction of the nozzle and the extruder feed to perform the print. Obviously, I have glossed over a lot of details here, most notably how to set up various options in the slicer software. For example, you may have to enable supports, which are basically little platforms that are built under parts of the model that would otherwise be hanging out in space. The printer can't print in the air. It has to build every layer on top of something. For a novice, the slicer software can probably do this automatically. You just have to recognize that it's needed. There's also the matter of infill, which is the structure that the printer constructs inside the enclosed parts of the model to strengthen it. This and a lot of other parameters can be manipulated in the slicer software. But the good news is that at least for simpler models, the software has defaults that are likely to work much of the time. There are a lot of YouTube videos on adjusting and optimizing all these things, but you really don't need to know all about them just to get started. So far I'm using the Creality slicer, which seems to do an okay job without a lot of help from me. I've also looked at the Cura slicer and the Prusa one, which probably have more options, but can still be used by an ignoramus once I grasp the basic idea involved. These are all free, by the way. The slicer will let you visualize how the object is going to be built up, and it will also let you orient it with respect to the base plate, which can affect how well it's going to print. However, most downloaded models are already in an orientation that worked for the person who built the model in the first place. So again, you may not have to do anything. The only thing I've actually printed completely on my own so far is this little clip that holds down the hood support rod in my SUV. The original broke, and this is one of 2 models I found to replace it. I printed it with and without supports, and it worked fine either way. I have several more projects lined up, but I actually just got home with the printer, and it needs a place to live in my overcrowded house. So we needed to do a little remodeling first before I can put the thing back together and start printing on my own. If you made it to the end of this video, I hope you got my 2 main messages, which are that 3D printing can be useful even for someone who's not interested in 99% of the things people do with it, and even a complete novice can get started without a huge amount of foreknowledge on the subject. Your comments are welcome. Likes and or subscribing will be appreciated. And thank you very much for watching.